So hello and welcome back. Let's pin this so we can see it. What's your name, please? I'm sorry? Up here, please. Thank you. Lots of it suck. Okay. All right, so Math 140. And this is now lecture 11, I think. Some of you might have noticed that lecture 10 was never put up on YouTube because there was some technical malfunction and not load. So far, come here, please.
Thank you. Sorry for coming in.
All right, question 8, chapter 8. A small chapter. Chapter 8 is on producing data. Producing data. Via sampling. And while it is a small chapter, there are actually some extremely important concepts in the chapter. That was not the light switch. Producing data via sampling. So suppose I were interested in the average height of every American. If I wanted the most accurate possible value, I'd have to check every single American. Is it really feasible to do so? Not really, for a number of reasons. One, how many Americans are there? A lot, very quantitative, huh? How many? Some more, 300 something million. Maybe it's even 400 by now. I don't even know. It's a lot of people. I can't do it myself. Maybe I can hire a team. How many people would it take to go and calculate and measure 330 million heights? Well, it will still probably take a very long time, no matter what size team you have, unless it's a team of like 1 million people, in which case, then you have interest in question is how much money you're going to spend on this. In the interest of money, time, resources, and in general, a job that big, by the time you're done, half the people that you measured are dead by now, and there's a whole new slew of people that you have to look at. So it's not really feasible. And even if you say, okay, but I'll find a way, I'll mail to every house in America, I'll do a census. America does a census every 10 years. You guys know this, right? Every 10 years they do it. It's a federal crime to lie on a census. Okay, the material on the census is used to dictate government policy. It's very important. Why can't I just do that? Mail a questionnaire to every house in America. Will that give me the correct value if I do it that way? Why not?
Not everyone's going to respond to it. Maybe someone's going to lie about it.
Well, it's okay. Well, there's always a chance someone lies. You know, you can't trust people. But even if everyone told the truth, does everyone live in a house? I mean, could you reach every person? No. So even if you wanted to, you couldn't. And even if you say magically, you know what, I'll find a way. Fine. How about we measure the average luminosity of every star in the galaxy? Okay, how are you going to do that one? Okay, good luck. Thanks. The fact of the matter is, sometimes you can't look at every data point that you want. So what do you do instead? You take a sample. You take a small or a subset of the entire collection And then the goal is to somehow take the sample, glean information from it that you think would apply to the entire collection that you're interested in. What do we call the entire collection? The population. So the population, this is the entire set of individuals of interest. And the sample is a subset of the population. Now, in general, if I want the best possible sample, there are certainly some criteria that I will want to satisfy. For example, if I'm interested in the average height of every American, and I ask 3 people, do we feel that would be a representative sample of every American? What's wrong with asking 3 people? It's too small. So there's certainly a minimum size that we would like to have to be a valid sample. That's the first criteria. Now, if I was truly interested in the average height of every American, would 10,000 people be enough? Do you think? That's a lot of people. 10,000 people, that's a lot of people. So what I'm going to do is I'm going to ask every single basketball player in college throughout America. There's like 10,000 basketball players in college. I'm going to ask every basketball player in a Division I school what their height is. Or maybe I'll measure them themselves. Nobody lies. Got to be about 10,000 people there. Is that a representative sample of every American? Why not? 10,000? Okay, so there's a bias there, right? The expected average of my sample is not the expected average of the entire population. Okay, there's a bias to my sample. That bias was kind of obvious. Not every bias is always obvious. So there's a lot that goes into questions like how to create a sample that is not biased, that is representative of the entire population. It's not a simple question. It's not something that's answered in one line. Textbooks can be written and have been written on sampling techniques. In this course, we're not going to do much. It's just the idea of sampling. So we're going to talk about different ways of sampling. Some of them are good, some of them not so good. And we'll try to list and try to understand which ones are good, which ones are not good, and why. So going through the book that I have here, because I left my hard copy at home. The first one that they have listed here in the chapter is, so option 1 is called a convenience sample. What is a convenience sample? It's a sample that is taken because it's convenient. Suppose I'm interested in the average height of every CSUN student. Right now, this second, at not 8:48, but at 6:48. Yes? No. No, I'm kidding. No. No, you okay? Well, that backfired. Okay, so a convenience sample is a sample taken because it's convenient. Okay, so let's say right now at this moment, I was suddenly interested in the average height of every CSUN student. What's a good sample for me to take right now at this moment? This class, it's like 30, 40 people here. Let's not even question whether it's big enough. It's convenient, right? You're all right here. Is a convenient sample a good sample? Not usually. It could be like here. there's no reason why abnormally tall or short people would want to take a stats course. It's not like, well, oh, business stats, oh, that's just for tall people. I mean, there's no reason why there should be a bias. So in this case, it might not be the worst situation. I don't know. But in general, convenience samplings are in general bad. A weird looking face. Convenience samples are in general bad. Then bad, poor, horrendous, atrocious.
Not accurate, not representative.
I kind of like my words, but yeah, okay, those work too. Not representative of the population for which it's trying to represent. Okay, so convenience samples are in general bad samples. The next type of sample that the book lists is called a voluntary response sample. What do you think, just by the name, a voluntary response sample is?
Get their answer.
Yeah, can anyone think of a situation where people volunteer to take the samples rather than you going and asking them, huh?
When companies pay for certain, like I know they do it on campus, like for samples.
Well, I'm asking, I'm trying to, I'm getting what you're saying.
I know, like, before the COVID, like, pandemic, they would pay you like $5.
No, they're paying you, that's not voluntary response, because they're coming to you and saying, would you do this? Is that what you're referring to?
You know,
If they come to you, then it's not voluntary response. Voluntary response means you're like, oh, I want to do this one. Yes?
online survey.
Online polls, I mean, you ever come across an online poll? You know, which Harry Potter school thing would you be? Houses, whatever. Sorry, I'm over two today. Sorry, I'm definitely in Dumbledore school, whatever that is. Anyway, so who responds to polls like that? Not everyone. I know I wouldn't. Okay, wow. He said that, not me. People that are interested in the subject. So in general, voluntary response samples are bad because they're not representative of everyone. Who responds to it? Oh, that subject really interests me, so I will respond to it. But if I don't care even enough to respond. So as a general rule, voluntary response samples are again bad. I was tutoring a girl, she's in New York somewhere, I forget which school, but she had to do a project where she had to actually analyze not just a news article, but the source of the news article. So she found some article on, anyone here from the Midwest or from the East Coast and knows what snow is? Okay, or has experienced snow and ice. So what do we do in the winter time when there's snow and ice in the road?
Don't leave the house.
Well, if we have to leave the house, what do we do? Okay, I'm gonna talk now, so you guys stop talking. We put ice or salt, we put salt on the roads. Because if we put salt on the roads from a chemical perspective, the melting point of the ice goes down, and therefore it's easier for the ice to melt. This whole article was about how the salt, which eventually makes its way into lakes and streams and rivers, has a very negative effect on the ecosystem, et cetera, et cetera, et cetera. I'm growing up, I'm like, yeah, we had the ice, we put it on, everything was great. I didn't even think about the negative effects. But I'm reading this article, and it's crazy how the article in the news magazine, which just summarized the actual article, left so much out about what kind of samples were taken and about how they were taken and about what they applied to. The details are missed usually when you're just cursory reading an article, cursorily? Word? Cursorily? I don't know, when you're kind of skimming an article. So the type of samples taken are very important. And most people just don't even think about it. So when you're actually doing research or looking at people's research, the type of way that they did the research is of course very important. Convenience samples, bad. Voluntary response samples, bad. The best type of sample to take, number 3, and spoiler alert, this is a good one, is nicknamed an SRS. An SRS. Now I will give you a hint. One of those S's does stand for sample. The R stands for random. You guys are really not doing very well today. And the other S stands for simple. A simple random sample. And a simple random sample is not just the best type of sampling technique, but later in the course, when we start. I'm sorry, what?
Sounds so stupid. That's why I'm surprised.
Well, let's just close this course down. No, a simple random sample is the most important technique for sampling. In fact, later on in the course, when we start getting into the formulas involved in sampling, almost every one of them, if not actually every one of them, will start off by saying, assuming that you have an SRS, then go ahead and do all this stuff. So if it's not an SRS, there's very little you can do statistically. The question is, what is a simple random sample? Was that your question?
Yeah, I was gonna ask why is it good?
Well, so let me answer that question. First, before I say why it's good, let's understand what is a simple random sample. Suppose I asked one of you to randomly pick 3 people in this room, randomly, in your head. I want every one of you to look around the room. Every one of you, look around the room, and I want you to, what you think is randomly, I want you to randomly choose 3 people. Okay? Everyone have their 3? Did anyone pick 3 people in the same column? Or the same row? Did you try to get one from there and maybe one from here and maybe one from here?
Yeah.
That's not random. That's not random. Random is when any 3 people in this case was as equally likely to be chosen as any other 3. The human mind can't really do random. What would be a way, a really fair way, to create a simple random sample in this room right now? If I said I want to pick 3 people at random, what would be the best way to do that? No, you had your hand up, just air in the pit a little, yes?
Give everyone numbers and like go on Google, put like a dice thing.
Okay, so an RNG, a random number generator. Maybe put everyone's name in a hat. And,
That was what
Yeah, both of them are excellent. Okay, the human mind can't do random because what we think is random is not really random. We think random is spaced out. But if it was truly random, we'd have clusters. We'd have a bunch in a row or next to each other. Because if it was truly random, then anything can happen. A simple random sample is when any sample is as equally likely to be picked as any other sample. So if I picked 100 Americans, out of the 300 million Americans that are out there, could I end up with 100 people who live in the same city? It might not be likely for that to happen, but it's still possible for that to happen. Yes.
There'd also be all individuals having equally likely chance of being chosen.
It is at all individuals, but it's deeper than that. That's just a random sample. A simple random sample is further than all individuals. It's all collections of individuals are as equally likely to be chosen.
All samples.
All samples are equally likely.
So you said it's any sample that.
A simple random sample is a sample where every possible sample is as equally likely to be chosen as any other samp.
Okay.
No, those are the words. What do you want me to say? I mean, understand, listen, you don't have to write this word for word. It's the idea that is important. Plus, it's in the book. You can always read it later and see what their words. A simple random sample of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. That's essentially what I said with different words. Okay, the idea is if you have a sample of size n, 5, 10, 100, whatever it is, any group is as equally likely to be chosen as any other group. That is what a simple random sample is. And the best way of getting a simple random sample is via an RNG. You guys all know what an RNG is? A random number generator. Use an RNG, a random number generator. Essentially what it does is it assigns a number to every one of the sample and then randomly picks numbers. Usually at the beginning of a semester, I might have my textbook from the previous semester that I no longer need. So the first day of class, we didn't do it this year because we were online. On the first day of class, I might show up and say, okay, who here has not yet bought the textbook and will like mine? And I'll have like 10 people raise their hands. And I'll say, okay, at the end of class, I will auction or raffle it off. What do? I give them all a number. I go to Google. I say, give me a number from 1 to 10. Boom, 7. Okay, who's 7? You? Here's the book. Okay, yes.
Isn't it true that there's really, literally no way?
Yes, even the computer is not technically truly fair. There's always some algorithm and some, it's not my area of expertise, so I can't really explain exactly what the problem is, but it's enough that the difference is negligible. Yes.
Is there a complex random sample that's simple?
I think a random sample that's just not simple is just called a random sample. I've never heard the term complex random sample used. It might be out there, but I've never heard it. Okay. An example similar, I was teaching my high school class the other day, and the book that they use is a European book because it's a European system. And in math, we talk about functions a lot. You guys all know what a function is, right? In math, f of x, functions. So one-to-one functions are very important in math. And in all my schooling, you had one-to-one functions, and then you had functions that weren't one-to-one functions. Well, this book talked about one-to-one functions and many-to-one functions. It's just a term that I never heard before. So perhaps it's out there. I just never heard it. Best I can say. Okay, with me so far? Okay. Here's another one. Number 4. Random digit dialing. Random digit dialing. What do you think random digit dialing is?
Randomly dialing.
Can't get anything by you. You're quick, man. So a random digit dialing is when you have your computer or whatever you're using, pick telephone numbers at random just to create a survey and dial. Why is the random digit dialing a bad method of getting a representative sample? It assumes everyone has not only just one phone, a phone, but specifically one phone. What if people have multiple phones and therefore they're more likely to be chosen than others? Of course, you have people who don't have phones. So random digit dialing is in general a bad method of sampling. There are other types. Yes, questions?
Is this only for numbers?
I think so. I'm not sure what other scenario it would be dealing with. There are other types of sampling that are actually pretty good. I didn't see them in the beginning of the book, but either they're not listed or they're listed later. Either way, I do want to mention them. So can I erase what we have so far? Okay. So what is that, 4 so far?
Yeah.
So 5 is stratified sampling. And this one's actually a pretty good method. It's not as SRS good, but it's pretty good method, stratified sampling. In stratified sampling, you first divide the population into groups called strata. And then you take a SRS from each of those groups. For example, what if I divide America into, I don't know, 50 groups and take an SRS from each one of those groups? Is there a situation you think that might call for something like that? Right, why 50? Well, maybe voting. Okay, so maybe I want to divide my population into 50 groups and look at each state individually and then take an SRS from each state. Or maybe I want to divide the population into males and females and take SRS from each gender. Of course, I know in today's day and age, gender is becoming more and more of a fluid idea. I'm referring more to my generation back in the day, just, not to make a big deal out of this, but it's the idea of breaking up a population into groups and then taking an SRS from each group. This would be what is called stratified sampling. Something similar is called cluster sampling. And people do get these confused quite often. Cluster sampling also a pretty good method of sampling. Nothing beats SRS, but cluster sampling is you still break up the population into groups. But rather than taking an SRS from each group, you just take some of those groups in their entirety. So the difference between stratified and cluster is in stratified, I might divide it up into 4 groups and take an SRS here, an SRS here, an SRS here, and an SRS here. And I get 4 little groups, each one from each strata of an SRS. Cluster would say, divide it up into groups and just take this one and not this and not this. You get all of this and you get all of that. So you're getting the groups in themselves in their entirety versus a piece of each one. Yes?
The selection of groups have to be random?
Yeah. Yeah, you would still want the groups themselves to be chosen via an SRS.
So what would be an example of cluster sampling?
So suppose I look at this class and I say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I divide up the group class into 10 columns based upon the row where you're sitting. And then I say, okay, rows 2 and 6, go do something. So I've divided the 10 groups and the entire group 2 and the entire group 6 are going to go do something. That's a cluster sampling. If I say one person from each group go do something, that will be stratified sampling. Okay, so in both cases I'm dividing into groups. Stratified, I take some of each group. Cluster, I just take some of the groups. Yes?
What's an example you would use in real life of each one?
Well, stratified, the example that I talked about, where you might want to look at each state individually. Okay, so I look at each state and divide each state into pieces, or divide up the population of America into each state, and then look at all 50 states and do an SRS from each one. That's certainly, I'm sure, a prominent method. Cluster sampling, I can't think of anything off the top of my head, but I'm sure if you do a Google search for, yes, you have one?
No, I'm just asking, so cluster sampling, would that be one of the excluding methods to use?
Would be one of the what?
Excluding method,
What's an excluding method?
to exclude a certain group, as you said, certain, examples, you don't have, for example, with the columns, certain columns are going to be doing something else. So let's say a different activity.
Yeah, but that wouldn't really be a sampling situation. I mean, it might be, like if you're running a class, if it's a small class, you might do it for an exercise of some kind, but I wouldn't really call it sampling. I can't really think of a cluster sampling.
The same thing you said, instead of randomly choosing.
Right, but I can't ask everyone in Hawaii and New York.
You
know,
could
so-
randomly choose states to sample and take all the samples from those states.
That's what I'm saying. So if I did that and I took all of Hawaii and all of New York, let's say, I can't think of a situation where I might do that. I'm not saying it's impossible. I'm saying I just can't think of a situation offhand where that might be, you know, a viable method of sampling. But maybe I'm a geologist. Just saw Tremors recently, you know, watch it again. Everyone see Tremors? No, huh?
Isn't that like,
Yes, yes, it is.
not like 19?
Yes, it is. Just one of the greatest movies of all time. Anyone, by the way, watch Barry this past weekend, like I asked? Anyone actually go ahead and do it? I was gonna give extra credit on the test. I was thinking about it. I could ask a Barry question to see who would have the answer. Nobody. Unbelievable. Unbelievable. You weren't studying. I saw your grades. What? Huh? No, I'm just kidding. What?
Chris Columbus make that?
It directed?
He did like Goonies and all those other.
No, Spielberg did. Robert Zemeckis did Goonies. But anyways, so as a geologist, maybe I'm looking at ground samples. So I divide up the ground into 50 regions, and then I look at you know, the entirety of a few of those regions at random. I don't know. I'm just spitballing here. I'm not really, to be honest, a statistician myself. It's not the field that I do. So, you know, I can basically explain this stuff, but in all honesty, I don't really practice it. All right. So, are there questions with the various samples that we've done so far? Of the 6 that we've done, which is the best? SRS, simple random samples. Okay, those are the ones we like the most. Those are the ones that we're going to do. We are in this class not going to actually be taking samples, but we'll be answering questions as the semester goes on about what to do given this sample, what to do given that sample. And a lot of the things that we develop will only apply if we are dealing with an SRS, a simple random sample. So yes.
How come simple random sample is like the only one abbreviated like SRS?
Because we say those words so often that we've chosen to abbreviate it. The other types just, I don't think I'll ever say them for the rest of the semester. You know, maybe a couple times, but simple random sample throughout the semester will be same. All right, so what are some cautions or things to worry about? When it comes to sampling. So one of them we've already mentioned, and that was bias. Now, bias has a technical mathematical definition. We talk about bias like, oh yeah, I asked all the the basketball players, you know, how tall they were, and oh, that's what got bias. So it's a qualitative term. We kind of have an idea what it means. But in statistics, bias is very, very mathematically precise. We're not going to worry about that. For this class, the qualitative term is enough. The sample has bias if the value that you get from the sample is not the value that you expect to get for the population. So if I take a sample of 1,000 people, or let's say 10,000 people, not tall people or short people, or just good old fashioned 10,000 people. And I take their average, the average of those 10,000 people. Do I think that that average should be in the ballpark of the true average of the every college-aged American? If I take 10,000 college students and I average their heights, do I think that should be in the ballpark of the average height of the typical college-aged American? Assuming it's random. If I take those same 10,000 people and I take the tallest person of my sample and I use that as my value, do I expect that to be in the ballpark of the typical college-aged American? No. Okay, so the second case has bias. The value that I get from my sampling technique is not the value that I expect to get for the population. And the first case does not have bias. So we don't want bias in our samples. 2, non-response. It's amazing. I teach statistics. I'm well aware of the problems with people not responding to surveys or polls. And yet whenever a poll is sent my way from the university, I instantly delete it because I don't have the time to do it. Or at least I just don't want to do it. Yes, I just don't care, okay? Non-response is just what it sounds like. You take a sample and people don't respond to it. Non-response is bad because all the people not responding might not be responding for a reason. What if I ask something like, how do you feel about current prison sentences for white-collar criminals in America? And I go around asking people, and all these people who have, relatives, friends, family members in prison or have had experience, whatever, don't respond, or this group doesn't respond, or that group doesn't respond because they feel uncomfortable with the question or this or that, I might not get an answer that is representative of the entire population. So non-response, if it's one person, I don't really know how big of a deal it is, but if it's a large amount of people who don't respond, that could be endemic of a non-representation of my sample versus the entire population, right? What's something else to be worried about? Undercoverage. This is the big one, undercoverage. What do you think it means, undercoverage? It's not about not enough people, huh? What?
You didn't meet the minimum, for example.
Well, again, it's not about the size. Although I guess it could sound that way. Undercoverage is more about missing out on a key demographic that makes my sample, again, not representative. How do you feel about the homeless situation in Los Angeles? Should we kick them all out? Who am I not asking that question to? The homeless, and there's a lot of them, right? So, the true feeling of Los Angeleans is probably not going to be reflected in my sample if I leave out that huge component of the Los Angeles population. Agreed? So again, I'm not in any way trying to indicate how I feel one way or the other, just an example. But undercoverage, again, is something that we do need to be worried about when it comes to taking a sample. 4, the wording. The wording. Or wording effects, I guess. Wording effects. Do you eat meat?
Yes.
Yes. You think it's okay to kill animals to eat them?
Yes.
Okay, I do too. But the point is, the way I phrase the question might encourage people to answer different ways, right? I just came up with that on the spot. I'm sure there's better examples. The book probably has better examples. How happy are you with your life in general? Scale of 1 to 10, how happy are you with your wife in general?
8 right now.
8? How many dates have you had in the last month?
How many what?
Dates have you had in the last month?
3.
Okay. Yeah, 3 more than me. Okay, so oh, did I say month? I meant 10 years. But anyway, the point is that the way that you word a question. You ever actually take like a long survey and you kind of feel like they ask the same questions multiple times?
Yes.
But the wording is a little different. So sometimes like you'll answer a question later, then you go back and say, wait a second, I asked it the exact opposite way before. Huh? What was that?
The stimulus, when they were giving out the 600.
Oh, really?
Yeah. they were giving 600.
Should we take a poll for that one?
No, like when you had an answer, there would be like some question.
Oh, for the Golden State, yeah.
Oh, gotcha.
Well, they do that for job applications too, right? I noticed that, I took one when I was,
Do they?
yeah.
It's annoying,
Like,
right?
It was the same exact question, but it was worded.
It's worded a little
the
differently.
Words were different.
Yeah, that could be enough. That could be enough to completely change how you answer it. Interviewer bias. Interviewer bias. Interviewer bias. Can anyone give an example where interviewer bias might play a role?
Interview, yeah, I would say an example would be a interviewer would prefer someone of a different race.
Yeah, sure. I mean,
Different race.
yeah, imagine I was interviewing someone African American and say, do you feel that white people are racist? And the guy's looking at me and he's like, oh, no, white people are great. Whereas if another African American was asking the same question, he might say, oh yeah, or something. I don't know, I'm just making an example. The point is, sometimes the interviewer, just by being you, can introduce bias into the situation. What are some other things? What else do they have here? Response bias. Response bias. What is response bias? Says the behavior of the respondent can cause response bias in sample results. Answers to questions that ask respondents to recall. Oh, yeah. What did you have for breakfast 10 days ago? Cheese? You had cheese? Oats? Oats?
My wife,
Huh?
my wife makes it.
Oats. What? Is that like cereal?
No, it's, yeah, overnight oats, so she puts like, oat milk, protein powder,
Huh.
Chocolate chips, peanut butter.
Well, that just sounds gross. But anyway, the point is, I'm allergic to peanut butter. That's why I say that. Some people forget. Some people just don't remember everything. I don't remember what I had 10 days ago. I know it was a lot more than just oats, just because it is every day. I mean, look, but you know, huh?
I'm not too far off.
I hear you, man. I wasn't gonna say anything, but I have a colleague here who about a month and a half ago, I'm walking down the hall and, you know, minding my own business, doing my thing, basically just ignoring everyone. And all of a sudden I hear, it's like, you know, hey, Bert, my nickname, hey, Bert. And I look up and I'm like, hey. And then I'm like, wait, who is that guy? And I stop. And I'm like, what? He's like, yeah, I know. I go, how much? He goes, 120 pounds. I go, 120 pounds. And they're like 9 months, you got 120 pounds. I go, how? He goes, just eat less. I go, yeah, that's the problem. Yeah, I know how to do it. Thanks a lot, man. But yeah, it's a miracle. I know, just losing weight is tough. Been trying it for, how old am I? My whole life. All right, so response bias is bias that results in the respondent. Either not remembering, misremembering, lying in general. Right? How tall are you? Oh, yeah, I'm 5'10". How much do you weigh? Oh, I weigh 180. All right. What the hell was that? What an asshole. So, yeah. All right. So any questions on this whole chapter, which by the way, we're done with the chapter. This whole chapter was non-mathematical. That's it. That's the chapter. Bias is when the value that you're using to estimate the true value, it's not expected to be in the ballpark. Huh? Again, I use different words each time. I can't, it's like response bias. I can't remember the exact words. The expected value of that which I am trying to estimate. I don't know what I said. What did I say? Someone repeat back what I said.
Expected average sample doesn't equal expected average.
There you go. Okay. Something, yeah. So I mean, it's a little more specific than that, but because it's not only about averages. Usually what's happening is this. There is a true value that I want to know. I want to know the average height of every American. So what I'll do is I'll take a sample and I will use my sample to get an estimate for that true value, correct? So the value that I get from my sample, I would like that to be in the ballpark of the true value, right? I want it to be close at least.
Just doesn't represent.
If it's not going to be in the ballpark, then we have bias. So that is chapter 8, producing data by sampling, very, very straightforward. But there's another way of producing data. This is chapter 9 now. Sorry? No, no math there. No math there. Chapter 9 is more of producing data. And this time it's by actually doing experiments. Producing data via doing experiments. In general, there are two ways of obtaining data. Observation versus experiment. When you do an experiment, you have control. You can separate your individuals into two groups. Give this one a placebo, fake medicine. Give this one a real medicine. I can monitor this, I can monitor that. You have control over what's going on. For an observational study, you have no control. You're just looking at the results. Suppose I'm interested in how smoking affects children when their mothers smoke. I'm interested in the effects of smoking on newborns. So I'm going to take 500 pregnant women, and I will have 250 of them smoke, and 250 of them not smoke, so I can look at the differences in their children. Is that a good experiment? No, that's pretty messed up, right? Okay, you can't do that. So in that case, I can't do an experiment. But if I go down to the local hospital and I say, hey, do you have any data on mothers who've given birth and their medical history have said that they've smoked? Oh yeah, we have all of these. Like, great, can I look at them? And maybe I can analyze the data. I'm observing data. I get what I need, possibly. I don't know what else they did. Did they drink? Did they do this? Did they do that? I don't have all the information, but at least it's better than nothing. So observational studies are when you just observe results, but you don't actually take part and do something. What's better in general, observation or experiment? No. Try again. I'm going to give you one more chance. You're so good. So yes, experiments. Because in experiments, you can eliminate lurking factors, lurking variables. You might not be able to do that with observation. If I'm interested in the smoking situation, did they also drink? Did they also do drugs? Were they working 10 hours a day? Do they have husbands that are abusive? Do they already have 4 kids under the age of 3? I mean, whatever the situation is, I have no idea what else is going on because I don't necessarily have the ability to control all that. So experiments are in general better, but I can't always, for morality reasons, for ethical reasons, always perform an experiment. Historically, there have been groups of people who have thrown ethics aside for the benefits of mankind and have decided that it's better to perform experiments on humans to get these medical results and not worry about the ethics. Can anyone think of some examples of that?
Dr. Joseph Mengele.
Dr. Joseph Mengele. Anyone ever hear of him? A Nazi scientist who decided to perform experiments on Jewish, possibly other demographics as well, but being Jewish myself, that's of course what I grew up with, groups for World War II for the benefit of mankind. Now, even today, you do have people who perform medical experiments, not on humans, but on animals for the benefit of mankind. I personally, I'm of the side of it's for the benefit of mankind, go for it. But there are certainly many people out there who do not feel the same way and feel that any harm to animals, etc., even for the benefit of mankind, is bad. There's lots of people out there. We all have different opinions. But with experiments, you have to worry, or at least be cognizant of the fact that sometimes there are ethical considerations. With observations, you just see what's there. Does that make sense? Okay. And here is something to worry about, especially for observation. I understand. So, two variables are confounded. Two variables are confounded when their effects on a response variable cannot be distinguished.
What's the definition of confounded?
This. Two variables are confounded. We're defining what it means. What does it mean for two variables to be confounded? When their effects on a response variable cannot be distinguished. Was it the smoking or the drugs that caused this child to have problems? I don't know. I don't know. Those two variables, they unfortunately, they just makes the data hard to decipher. That's just an example. I'm sure there's others. So confounding, is that good or bad? That's bad. That's really bad. A good experiment tries to remove any possibility of confounding. You know, males and females might have different, you know, whatever. So let's separate males and females and do the experiments separately so that the results that we look at are not confounded with gender. Perhaps different weight classes should be separated. You know, 250 and up, 200 to 250, let's separate those because weight is an issue. And I don't want the results of a 250-pound person and a 150-pound person to be grouped together because I can't really tell, is it my thing that's doing it or the weight that's doing it? Whatever the case may be, confounding is bad. Experiments, good experiments, do their best to eliminate confounding. Observational studies, you can hope that there's no confounding. Oh, I have my data report here. It says smoking and drinking, only drinking. Great, okay, I can eliminate that confounding possibility, assuming they didn't lie, of course. Does that make sense? So confounding, bad. Yes, exactly. Now, in the language of experiments, when doing an experiment, we have some terms that we use. So in experiments, the subjects. What are the subjects of an experiment? Yeah, the subjects are the individuals. The subjects are the individuals. The factors What are the factors of an experiment?
What you're basing it on?
Yes, but I want to be a little more precise. What kind of variables? And what do we call those? The explanatory variables. The factors are the explanatory variables. And the treatments what are the treatments in an experiment? No, the response is the response. The treatments are,
What's being put onto the subject?
yeah, so the treatments are like what I'm doing to all my subjects. Like I'll give this one the actual medicine, I'll give this one the placebo. So the words of the book, the treatments are the experimental conditions. Are the experimental conditions applied to the subjects. Or I'll put here, or a combination thereof. So perhaps I have 10 different treatments. So I assign various experimental conditions to all my cases. So I might have, these conditions for this one, and these conditions for that one, and these conditions for that one, and these conditions for that one. So you have the subjects, you have the factors, and you have the treatments. These are not terms that are used in observations because they don't apply. Chapter 9, by the way, is also a non-mathematical chapter. Yes, we're not done with it yet, but
What does the second part mean for the treatment or condition thereof?
the experimental conditions, so I might have multiple conditions for each treatment. I took a course once a long time ago on on experiments design and how to block the data to get, if you have multiple factors and treatments and analyze your data. I don't even remember the math. It wasn't hard math, but I don't remember how to do the math offhand. It wasn't so straightforward. Okay, so can I erase this? Question?
Control?
I'm sorry?
Control, is it gonna be more?
Well, when we talk about the experimental conditions, one of them might be not having any treatment other than just like the placebo or not doing anything. That's what we call the control group. It's just one of the treatments is the control.
But you say observation, no control. That's not the same thing.
One more time, I'm sorry.
You said observational means no control.
Observational is no control, that's correct.
You could have a control group.
Well, I can look back on my study and compare having this, not having this, but when you have a control group, because you have control over it, with the observation, you have no control over it, you're just looking at the data. Maybe someone else had control over it, but you're not having any control over it.
No, I know, but you could still have a.
It can have a control group, but it's not your control, yeah. So, randomized comparative experiments. Randomized comparative experiments. Like the SRS is your best possible sampling technique, the randomized comparative experiment is your best possible experimental technique. Because what you're going to do, you're going to have your sample. How do you get your sample? Maybe an SRS, maybe a stratified, whatever you choose. But you have your sample. And then what do? You split your sample into groups and you perform a different treatment for each group. And then what do you do to the results? You compare them. But it's important to do a number of things for a good randomized comparative experiment. When you decide to split up your sample into groups, how do you pick which group goes where? SRS. Random. You got to make sure that your treatments are randomized. So the first thing we need, randomization. Anyone here watch the great medical drama, Grey's Anatomy? I've been on the air for 19 years. Started it thinking it'll be over soon because it's not really that good and it's still going on. And my God, I'm still watching it. But I remember like in year, I can't even say what year it was, but a long time ago, many, many years ago, there was a situation where they were doing a FDA testing of some drug that was supposed to work miracles. I think it was on Alzheimer's. And the title character of the show, Dr. Gray, saw that someone she liked was getting the placebo. So she switched her and put her to the other group so that she can get the actual medicine. It's caused a whole big to-do because it nullified the entire experiment. Because we no longer have randomization and you know where it's going, who's going where, even if it's one person. Randomization, okay? The breakup of the sample into which treatment you get needs to be random. Next, replication. What does replication mean?
The experiment should be able to be replicated.
Yes, do it a lot. Don't just have one person in each group. Replicate the experiment. Doesn't mean, I think what you said, which is somebody else should be able to come along later and replicate it. That's more like in physics or chemistry when you say, hey, I did an experiment, this is the result that I got. And someone's like, well, let me do it and see if I get the same result. This is more, do multiple runs of the same treatment. Don't just have one for each one. Okay, because what if I'm testing the new medicine? I have this wonderful medicine that cures headaches so much faster than Advil or ibuprofen. And I give it to one person, they say, my God, my headache went away in 5 minutes, amazing. Well, maybe it would have went away anyway. It's only one person. Do it to 100 people and see if the average is less than it would be for Advil or ibuprofen or one of the other ones. Replication, multiple results. Randomization, replication. When possible, double blinds. What does a double blind experiment mean?
The person conducting and the people taking it don't know what it is.
Excellent. Well, not what it is, but what treatment they're getting. The people conducting the experiment and the people who are receiving the treatments do not know which group they are in. Why is it important for the people who are running the experiment to not know what group everyone's in?
Bias.
Well, yeah, bias. Like, oh, these ones are getting the medicine. Let me give them a little extra treatments. Spend a little more time with them than the others. That's an additional factor. Confounding, yes.
Why would they do that?
Why would they do what?
Like that example, they spend more time with.
If I'm testing a new, cancer treatments, and I know those ones are getting a fake one, and these ones are getting the real one, where would I want to spend more of my time? The real one, because they're not getting anything, it's fake anyways. Here, right, interns, you do that one. I'm going to go with these guys. But the whole point is to have the same exact approach, because you don't know, if you don't know, you'll do the same thing for both. We remove the possible of another confounding variable, confounding factor, and so on. And of course, the people getting the experiment, they don't want to know what it is, or we don't want them to know what they're getting. Oh, you're getting the placebo. Oh, okay. Well, I mean, that's just, that's just silly. So, what else? Randomization, replication, double blinds. What else we have here? That might be it for chapter 9. Oh, there's a couple other things here. So we have what are called, and we'll do a little bit of this later in the course, matched pair designs. A matched pair experiment What is a matched pair experiment? Well, let's think about that. Suppose I'm interested in whether a person's dominant hand or their non-dominant hands, how much better, like if I'm hammering a nail, let's say, how much better a person's dominant hand is versus their non-dominant hands. So how many swings of the hammer is enough to nail a hammer in with their dominant hand versus their non-dominant hand. So I'm going to do the following. I'm going to ask 100 people, take a SRS of 100 people and do their dominant hand, and then take an SRS of 100 people and have them do their non-dominant hand. Or I can do the same 100 people, dominant hands and non-dominant hands. Which of those is the better designed experiment? The same person, because you are eliminating additional factors that might be present. You are matching your data sets, right? It's a matched pair, right hand, left hand, or dominant hand, non-dominant hand. If it's a couple, I'm going to ask 100 husbands how they feel about something, and I'm going to ask 100 wives how they feel about something. Well, maybe asking a husband-wife pair might be better. Match them up. A matched pair design. In chapter 20-something, we will have a little bit more to say about matched pairs. Here, we're just getting the basic ideas. I can have a block design experiment. Again, what's a block design? Well, I want to do this experiment, and I noticed that a lot of people are very similar in many ways, but those people are very similar in a completely different way. And those people are very similar in a completely different way. So maybe I will block them and do these ones with one treatment and those with one and those with one. I will put them into blocks of similar or do an SRS or each one. So maybe I'll block them and then break up each block into different treatments so that I again remove the possibility of a confounding variable.
So you simplify it by characteristics?
I can simplify it by similar characteristics. Maybe I'm looking at how quickly people are affected by the sun. You're outside, how long does it take before you get a sunburn? So perhaps I might want to split it up by race. So, or maybe I'm testing a different suntan lotion to see, or sunburn preventive, whatever, to see how effective they are. I might take all of the Caucasians and have the control group, the treatment group, et cetera, for them, and the African Americans and those and those. I might want to divide them up into blocks before doing anything else, because again, it might remove a confounding variable. Same treatment, yeah, the same treatments in each block, but I separate it by blocks because I feel that the blocks design might lead to better results. Yes.
Could you modify it so like for that experiment, you give the lighter skinned people more lotion?
But then if you do that, then you're just introducing a new variable. How much lotion is a new effect, a new variable, and that ruins everything. You really want to be exactly the same. But if you feel that the skin color might have a huge effect on the results, you first block it by that and then work from that. And so on. Yes.
So it's kind of similar to stratified?
Kind of similar to stratified, yeah. Well, stratified is a little different. There you split them up and take an SRS for each one. Here we split them up and we split each one into different treatments.
Okay.
So if I might, something like block 1, and then just to keep it simple, 2 blocks, block 2, and then block 1, the control and the treatment, and block 2, the control and the treatment, something like that, versus just a regular control and treatment. And that takes us to the end of chapter 9. Okay, so 8 and 9 will be good for today. 8 and 9 are non-mathematical. Today is Thursday. So I'm going to give you for these 2 chapters, I'm going to give you to the following Tuesday. but there'll be no quiz on either of them. Because they're just definitions, there's no math. When we return on Tuesday in week 7, we're gonna start working on some more mathy stuff. So be prepared. Okay. All right. Yeah, the test is all yours.